So I'm making this recording for AEM 535, Applied Finite Element Analysis, as just an introduction to the ABAQUS interface. And to give a little bit of a historical background about ABAQUS, I've been using ABAQUS since probably 1992, when we had version 4.8 available, and it's evolved quite a bit over the years. And so I want to go through the interface, describe some of these features and options that we have, and some of the philosophy that ABAQUS has used from my perspective in the past and currently, and how that affects the way that you set up your model and analyze and get your results. Take a look at them. So when we first start up ABAQUS, and this is 6.14-2, if you use a later version of ABAQUS, this may look a little bit different, but I expect the main features to remain the same. When you start up ABAQUS, you'll have a little window that pops up that wants to know if you want to open recent files or anything. I've already closed out of that. I have multiple computer screens, and it wasn't on my recording screen, and I had to close that out before I could start this recording up. So I've X'd out of that, and this is what you'll see. Along the top, you see the usual type of Windows commands: file, model, viewport, and so forth. And then you'll see a series of icons, and a lot of these icons are the same as if you were to go into one of these underscored options along the top and do something here. So it's just kind of a shortcut. Now these toolbars are customizable. You can take these, you can move these around, you can put them on different lines. You could add toolbars, quick toolbars to your setup. And this main display is your model or viewport display that we have here. This is where our model will show up. Over on the left hand side, they call this the model tree. There are multiple models that you can have, and you can make different parts in your model, define materials, set up sections like a solid section or a cell section, look at profiles such as pipe cross sections, and make an assembly out of various parts. This is a feature that's been emphasized in the last few versions of ABAQUS, and it's a little bit different if you're used to just using finite element codes without a fancy graphical user interface, but it's fairly convenient, and it's the way things are going. Now historically, ABAQUS was developed by some professors at Brown University, Hibbett, Carlson, and Sorensen, and they didn't really have a fancy preprocessor like we have now. All this GUI stuff didn't exist. So it was mainly just a solver. You set up your input file using some other preprocessor, or set it up by hand, or I guess in the really old days you'd use a Fortran punch card deck. But those days are past, and so we have this nice GUI. That said, we can still use editing of the input file, or it's called the input deck, to make hand edits and then run those with the solver outside of the graphical user interface that we do see here. This after HKS sold ABAQUS to Simulia. Simulia is the company that is in France that owns CATIA and has developed CATIA. They've introduced a lot of features that I think are probably very familiar to CATIA users, and have incorporated the ability to import geometry and CAD data directly from CATIA and a few other places. But it's getting to be more seamless with CATIA. I guess I should say that. Now, I'm not a CATIA user, but if you are, hopefully things will look kind of familiar. So there's the assembly, and we'll talk about some of these different things as we go through this discussion. And here are the steps that you would have in your model, and we'll talk about these. But basically the steps are individual sequences of load. So you might say, I want my part to move 3 meters to the right. That might be one step. Your second step might be, now I want my part to move 2 meters downward. Or the third step might be, at this point I want to apply 20 kilonewtons of force at node whatever using a ramp of a certain frequency, and I want to output my stress results at a certain so many units of time. All of that is in the step. We have field output requests, time points, adaptive mesh constraints, interactions, interaction properties, and different contact controls, constraints, and so forth. And a lot of these things can be initialized in the step, and they will show up here in this list. So you may see some things populating in here and inside the step at the same time. Annotations are just mainly for putting decorations on the screen, whether it's words so you can keep track of things, or arrows and so forth. And then down at the bottom is the analysis portion, where we have the jobs, adaptivity processes, co-executions, optimizations, and so forth. After your job is completed, you'll go over here to results, and then you can import your results and take a look at different ways to display it, whether it is an XY plot of your data, stresses as a function of time, so forth, or you can plot a contour plot of your component that has different colors corresponding to different stresses that you may already be familiar with. Over here on the kind of the center panel next to the display window and above it are these different modules, and different modules have different features that you can apply in that module. So this one that I'm highlighting right here says create a part, and if you notice there's little triangles on some of these are flyouts, and if you click and hold you can access other icons that are existing on that flyout. They usually have a common theme. And as you get used to Abaqus, you'll be familiar with what some of these different little icons mean. Now the modules are kind of important, and they basically go through in the order in which you would want to create a component and give properties to the component, assemble it, create the steps, make sure you have the correct interactions, apply loads, maybe edit your mesh, do optimizations. There's the job menu, visualization, looking at stress results, and then down at the bottom they have sketch, which is kind of a weird place for that, but we'll talk about that soon as well. So these different modules allow you to have different icons over here, and they each have their own set of flyouts and so forth. And so for example, this one you see sigma epsilon. This allows you to create a material such as setting a stress strain curve, for example, but there are lots of other things you can do besides that in the material option. It can be linear, it can be linear elastic, non-linear elastic, can be elastic plastic. You can give stress strain input with temperature and all sorts of different features. Okay. To the right of the property is the model, and right now all we have is model 1, but we could have multiple models in here, and we can pretty quickly switch from, for example, model 1 to some other model. And in the model there may be various parts. We haven't created any part yet, but if we did, it would go in here, and we can select it. Alright, so that's I'm probably going to make several short videos that go along with this, that will start out then next with creating a very simple, and I do mean a very simple type of part, and apply some loads and boundary conditions. And the purpose is not necessarily for learning anything from the analysis, but more to start to get you used to using these panels in the graphical user interface.